Hello friends, welcome back to our channel Aha Zindagi Educare. Our channel provides online video lectures for maths and science from class 8 to class 12. Please visit our playlist section to get the benefit of free online learning materials. Okay friends, coming back to relations chapter, this is the second lecture of relations. In the first lecture, we have covered ordered pairs, equality of ordered pairs, Cartesian product of sets. Also, we have seen how to calculate number of elements in the Cartesian product of two sets. Then we have discussed graphical representation and diagrammatic representation of Cartesian product of two sets. So those who have not gone through first part of this chapter, please go through the first part of this chapter. I will put link in the description box, or you may visit playlist to get the same. After going through first lecture, you will easily understand this lecture. Okay friends. So today in this we will discuss some important theorems and we will see proof of those theorems. Okay friends. So some important theorems or results. Okay. So first theorem is for any three sets A, B and C, for any three sets A, B and C, prove that first part is A into B union C equal to A into B union A into C. So we have to prove this second part A into B intersection C equal to A into B intersection A into C. So for solving this type of problems, one should know or should be familiar with sets chapter. So also please go through sets chapter before doing this. Okay. So we will prove first one. So for doing A into B union C, we will consider let A B, okay, this ordered pair be an arbitrary element of A into B union C. Okay. So as we have considered AB as an element of A into B union C, from this we can write A is an element of A and B is an element of B union C. This can be written as A is an element of A and B is an element of B or B is an element of C. So We can write this: A is an element of A and B is an element of B, or A is an element of A and B is an element of C. So this we may write as A, B is an element of, okay, here see, A is an element of B and A is an element of A and B is an element of B. So ordered pair AB is an element of A into B, and from second one we will get ordered pair AB is an element of A into C, A into B and A into C. From this we may write as AB is an element of A into B. Since here it is all, so we will write union A into C. Okay, so it implies that, or from this we can deduce that A into B union C is a subset of A into B union A into C. Okay, next we will consider opposite way. So what we will do, we will take any arbitrary element of A into B union A into C. So let x, y be any element of A into B union A into C. So x, y is an element of A into B union A into C. This one is 1. So this we can write as xy is an element of A into B, or xy is an element of A into C. This may be written as x is an element of A and y is an element of B and y is an element of B, or x is an element of A and y is an element of C. Okay, so from this we can write x is an element of A and y is an element of B, or y is an element of C. So this can be written as x is an element of A and y is an element of B union C, as it is or. So this we may write xy is an element of A into B union C. Okay, it implies A into B union A into C is a subset of A into B union C. It is our second point. So from 1 and 2, from 1 and 2, we may write, okay, A into B union C is equal to A into B union A into C. Okay, this we have written because if two sets are such that A is a subset of B and B is subset of A, then A must be equal to B. This we have seen in sets chapter. Okay, friends. So using that result, we have written from 1 and 2, A into B union C equal to A into B union A into C. Similarly, like first one, we can prove this second relation only in place of union. Here it is. Okay. In place of union only, we have intersection. So we will follow the same procedure and we can get this result. Okay, friends. So next theorem is, let me clean this. Second theorem. Second theorem is for any three sets A, B, and C. A, B, and C. A into B minus C. Okay, A into B minus C equal to A into B minus A into C. Okay, so we will see the proof of this one. Here also we will follow like the previous one, same procedure. Let AB is an any element of A into B minus C. Okay, so we can write AB is an element of A into B minus C, and this we can write as A is an element of A and B is an element of set B minus C, and this can be written as A is an element of A and B is an element of B and B is not an element of C, as it is B minus C, not an element of, so I will write it clearly. So B is not an element of C. Okay. And this may be written as A is an element of A and B is an element of B. Okay. Then we will write and A is an element of A and B is not an element of C. Okay. So this we can write as AB in the form of ordered pair. AB is an element of A into B and AB is not an element of A into C. Okay. So from this we can write AB ordered pair AB is an element of A into B minus A into C, or can write from this A into B minus C is a subset of A into B minus A into C. So we will write this equation as first one. Next, we will take any element in the right side shape. Okay. So if xy is any element of A into B minus A into C. Okay, so this we can write as xy is an element of A into B minus A into C. Okay, so this can be written as xy is an element of A into B and xy is not an element of A into C. This we can write as x is an element of A and y is an element of B and x is an element of A and y is not an element of C. Okay, so from this we can write x is an element of A and y is an element of B and y is not an element of C. From this we will get x is an element of A and y is an element of B minus C. From this we can write ordered pair xy is an element of A into B minus C. And so we get A into B minus A into C as xy is an element of A into B minus A into C. So this is a subset of A into B minus C. Okay friends, this is our second part. So from 1 and 2 we get A into B minus C is equal to A into B minus A into C. Okay friends, so we will now see another theorem, theorem 3. Theorem 3 is if A and B are two non-empty sets, A and B are two non-empty sets, then A into B equal to B into A if and only if A is equal to B, or if A into B equal to B into A, it implies A equal to B and vice versa. Okay, that is if A equal to B, then also A into B will be equal to B into A. So we will see proof of this theorem. So how we can start? So we will start with let A equal to B. We will start from there. Then we have to prove A into B equal to B into A. So we have to prove A into B equal to B into A. Okay. So A equal to B. So we can write A into B equal to A into A. Okay. And we can also write B into A equal to A into A. Why? Because A is equal to B as set A equal to B. Okay. So A into B will be equal to A into A, and B into A will also be equal to. So from this we get A into B equal to B into A. Okay. So next we will try to prove vice versa, or conversely, let A into B is equal to B into A. So in this case, if we are considering this relation, then it we have to prove it implies that A equal to B. Okay. So this we have to prove. So we will take any element, let X be any element of A. So we can write X is an element of A and X B is an element of A into B for all B is a element of shape P. Why we are doing this? Because A into B equal to B into A. So this can be written as XB is an element of B into A, since A into B is equal to B into A. We are using this relation here. So this can be written as X is an element of B, because this is from this ordered pair. First element is from first set. So this gives X is an element of B. Therefore, X is a we can write X A. Just a minute. X is an element of B. It implies that A is a subset of B. This is our first one. Then we will take another element. Let Y is an element of set B. So we may write Y is an element of B, implies that ordered pair AY is an element of A into B for all A is an element of set A. Okay. So this we can write AY is an element of B into A, as A into B is equal to B into A. This is we have already considered. So from this we can see Y is an element of A, or we can write B is a subset of A. So from 1 and 2 we get A equal to B. So both we have done. A, for considering A into B equal to B into A, we have proved A equal to B, and here we have taken A equal to B. Then we have came to the conclusion that A into B equal to B into A. Okay, friends. So we will see next theorem. Let me clean this. Fourth one. If A is a subset of set B, so that A into A is a subset of A into B intersection B into A. So how we can prove this? We'll see this. We'll consider an ordered pair AB. Okay, let AB is any element of A into A. So this we can write as AB is an element of A into A. It implies that A is an element of A and B is an element of A. From this we can write A is an element of A. Okay. Then B is an element of B and A is an element of A. B is an element of A. Okay. A is an element of A. Then B is an element of, okay, it is also A. A is an element of A, B is an element of A, and we can also write A is an element of A, B is an element of A. Okay, so this we can write A is an element of A, B is an element of B, and A is an element of B, and B is an element of A. Why we are writing this? Since A is a subset of B, therefore if AB is an element of A, it implies that A, B are also element of B, and this relation is given. Okay, it is given. See, A is a subset of B. Okay, so this we can write AB is an element of A into B and AB is an element of B into A. So from this we can write AB is an element of A into B intersection B into A. So from this we get A into A is a subset of A into B intersection B into A. Okay, hence we got the result. If A is a subset of B, it implies A into A is a subset of A into B intersection B into A. Okay, friends. So let me clean this. Next theorem is fifth. If A is a subset of B, then A into C is a subset of B into C for any set C. Okay, so if A is a subset of B, we can write A into C is a subset of B into C. So how we can prove this? So we will consider any element AB is any element of A into C. Okay, then we can write AB is a subset of A into C. From this, we can write A is a subset of A and B is an element of C. A is an element of A and B is an element of C. From this, we can write as A is a subset of B. So A is an element of B also and B is an element of C. Since A is a subset of set A is a subset of B, so if A is an element of A, B it implies B is an element of sorry A is an element of B also. Okay, so from this we get AB is an element of B into C. Okay, AB is an element of B into C. Therefore, we can write A into C is a subset of B into C. Okay, friends. So we will see another theorem, sixth one. If A is a subset of B and C is a subset of D, then A into C is a subset of B into D. Okay, how we can prove this? So again we will consider an ordered pair. AB is any element of A into C. Okay, so we can write AB is an element of A into C, and this we may write A is an element of set A and B is an element of set C. So this we can write A is an element of set B as set A is a subset of set B. So if A is an element of A, it will also be an element of B. Similarly, B is an element of C implies that B is also an element of set D as C. We can write A is a subset of B and C is a subset of D. So we can write this, and from this we can write AB is an ordered pair or is an element of B into D. Therefore, we can write A into C is a subset of B into D. Okay, friends. So let me clean this. Then we will see next theorem. Next is our seventh. For any set A, B, C, D, there are four sets. Prove that A into B intersection C into D is equal to A intersection C into B intersection D. So how we can prove this? How we can do this? So we will again consider an ordered pair AB is an element of A into B intersection C into D. So this we are considering. So this we can write AB is an element of A into B and also AB is an element of C into D. So this we can write as A is an element of A and B is an element of B, and A is an element of C and B is an element of D. So this we can write as A is an element of A and A is an element of C after rearranging, and B is an element of B and also B is an element of D. So this implies A is an element of A intersection C and B is an element of B intersection D. So from this we get A is an element of A intersection C into B intersection D. Okay, so we can write AB, sorry, here it will be AB. Okay, ordered pair AB is an element of A intersection C into B intersection D. So from this we get A into B intersection C into D is a subset of A intersection C into B intersection D. Similarly, we can prove A intersection C into B intersection D is a subset of A into B intersection C into D. So and 2, from 1 and 2, we get A into B intersection C into D equal to A intersection C into B intersection D. Okay, friends. So, next theorem 8. For any three sets A, B, and C, A, B, and C. First one is A into complement of B union complement of C and complement of pole is equal to A into B intersection A into C. Second one is A into complement of B intersection complement of C and complement of B intersection C complement is equal to A into B union A into C. Okay, so how we can prove this? First we prove one. So we can write A into B complement union C complement and whole complement is equal to A into B complement, okay, intersection C complement, complement of C complement. This is by De Morgan's law. Please see the set theory. Okay, for this law we have proved this one also. So this we can write A into B intersection C. Okay, and this is equal to A into B intersection A into C. This is we got from theorem 1. Just now we have proved. Okay. So second one is A into complement of B, complement of C and whole complement equal to A into B complement, whole complement, union C complement and whole complement. So this we can write as, this is by De Morgan's law. So this can be written as A into B union C, and this is equal to A into B union A into C from theorem 1. Okay friends, so let me clean this. Next we will see another theorem 9. See, remember all these theorems, because one the result of one theorem will be used in another theorem, and also to solve problems we may directly use these theorems. Okay friends, so if A and B be two non-empty sets, having n elements in common, then A into B and B into A have n square elements in common. Okay, so how we can prove this? See, we have from theorem 7, we can write A into B intersection C into D is equal to A intersection C into B intersection D using theorem 7. Okay, so this we can write A into B intersection B into A is equal to A intersection B into B intersection A by replacing C by B and D by A. Okay, C by B and D by A in the theorem 7. So from this we get A into B intersection B into A equal to A intersection B into A intersection B we can write. So it is given A intersection B has n elements, as A and B has n elements in common. So A intersection B has n elements. We can write as, it is because since A and B have n common elements. Okay, so we can write So A intersection B into B intersection A has n square element. Okay. So, but here we can see A into B intersection B into A is equal to A intersection B into A intersection B. This is from here one, from 1. Okay. Therefore, A into B intersection B into A has n square element. Therefore, A into B and B into A have n square elements in common. Okay, so let me claim this. And next theorem is, let A be any empty set, non-empty set such that A into B is equal to A into C, then B should be equal to C. So if A into B equal to A into C, we have to prove B equal to C. So how we can prove that? We will take any element, let B is any element of set P. So we can write ordered pair AB is an element of A into B, for all A is an element of A. So from this we can write AB is an element of A into C, since it is given A into B equal to A into C. Okay. So from this we can write B is an element of C. Thus B is an element of B implies B is an element of C. Therefore we can write B set B is a subset of C. Okay, this is first relation. Next we consider, let C be any element of set C. So we can write AC is an element of A into C, for all A is an element of set A, and this we can write AC is an element of A into B, as it is given A into B equal to A into C. From this we can write C is an element of B. Thus C is an element of set C implies that C is an element of set B also. Therefore set C is a subset of B. So from 1 and 2 we get set B must be equal to set C if A into B equal to A into C. Okay friends. So we have discussed some important theorems and its proof. I hope all of you have understood the lecture. If any of you have any doubts or you have any query regarding this topic, please let me know in the comment box. I will try to resolve your doubts. And if you have seen the whole video and liked it, please like the video and subscribe our channel Aha Zindagi Educare. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.